For today's lesson, we're going to simplify expressions using scientific notation. For the big idea, please determine whether 10,000 is a large number or a small number. And as you consider that, let's think about 1 over 100,000. Now, in my opinion, this is a large number when you consider the unit 1. If we're going to write it in the exponential form, it should be 10 to the 4th power. You have 4 zeros, which means that you've multiplied 10 4 times. Now, if we think about the unit number 1, for 1 over 100,000, this is a small number. And when we rewrite this as an exponent, you might write it as 1 over 10 to the 5th power because it has 1, 2, 3, 4, 5 zeros. Now, just to be clear, this small number could have been written as 10 to the negative 5. So if we're going to compare numbers to the number 1, we will let A be considered a large number and B considered a small number. Now, just so we recall from previous ideas, anything to the 0 power is equal to 1. Anything with a negative power can be rewritten as 1 over a to the n. And if you have a to the n, it can be rewritten as 1 over a to the negative n. Properties for exponents. When you multiply like bases, you're going to add your exponents. If you divide like bases, you're going to subtract your exponents. Now, as we look at scientific notation, it has always to be written in the same form. You will have a number in the ones place, one number only in the ones place. A decimal must be written, and then you have as many numbers as necessary after the decimal. You can rewrite this times 10 to the some power. Now, this could be 10 to the 6 or 10 to the negative 6, but it's always in the form of a number, a decimal, times 10 to a certain power. Now, as you consider large and small numbers, we're going to consider anything with an exponent that's positive as a large number, and anything as an exponent with a negative as a small number. That's just so that we can have a conversation as we look at each problem. As I'm looking at number 1, I have 52,000. As compared to the unit 1, that looks kind of large. So in order to write it in scientific notation, notice the decimals after the 4. We would move the decimal 1, 2, 3, 4 places. This is a large number compared to the number 1. So we're going to write this as 5.2314 times 10 to the 4th power because we've moved the decimal 4 places. It's now in scientific notation. As I look at example 2, notice I have my number 3, my decimal, something following, but I do not have times 10. So in order to rewrite this problem, we're going to write 3.2 times 10 to the 0 power. Now it's in scientific notation. This number looks small, so I'm going to move the decimal 1, 2, 3, 4, 5 spots to get the decimal in the right position. 4.28 times 10. Since it was a small number, it's 10 to the negative 5. Our last example for this one looks like a large number. So we're going to move the decimal so that we have 6.02. Count that we've moved 3, 6, 7, 8, so times 10 to the 8th power. A large number, positive exponents. Now we want to go from scientific to decimal notation. Notice where my decimal is, and I want to move it 3 spaces. I'm going to move it to the right because I want to get a larger number. So 2, 5, 6, fill in a 0 as a place value. Our second problem has a negative exponent, so we want a number that looks small. Negative point, let's put a 0 first, 0 point, and how many places do we want to move this decimal? 5 places, 1, 2, 3, 4, 5. So we're going to fill in 4 zeros, then we'll have our 3, 5, 6, 7. Next one, we have a positive exponent. We want a larger number. 4, move that decimal 4 places, and we now have 40,000. Our last problem. It needs to be a small number because it was a negative exponent. So we're going to have 0 point, moving the decimal 8 places to the left. And what we're going to end up with is 7. Here's my 8, 4, 2. So it's definitely a small number. Now, when we multiply in scientific notation, you're going to start by multiplying 3.2 and 7.4. And we get a 23.68. When we multiply 10 to the third times 10 to the negative 12, we'll have times 10 to the 3 minus 12, which is negative 9. So we have 23.68 times 10 to the negative 9. Now I want my answer in scientific notation. Notice the decimal is not in the right place. So it's 2.368 times 10 to the negative 8. For example 4, we start with 9 divided by 2, which is 4.5. 10 to the 8th divided by 10 to the 3rd is going to be 10 to the 5th power. Subtract your exponents. So this one is already in scientific notation. We didn't have to make any more changes. So try the following problems and then come back and check your work. For the word problems, make certain you read them carefully so that you can set them up and then use scientific notation to answer your questions.